I was talking with an Algebra 2 student that I teach on Saturdays, and they're doing exactly the same thing. And so I talked to her about Kramer's rule, and she had not learned it. She did not know Kramer's rule because apparently they didn't teach it when they went through either that or she didn't remember it. And so when we went over how to do Kramer's rule, she goes, "Wow, that's fast."
Right?
Because it does take some of the time-consuming part out of solving equations. Now, when you get done using Kramer's rule, you have the x and the y, right? When you put them into a point, you have the solution to the equation. Now, that's detestable. What do I mean?
What?
It's detestable. It's on detest.
Oh, gotcha.
All right? So what did I just say before I said detestable? What is it? When you take the x and the y and you put them in a point, it's called the solution. It's called the solution of the system of equations.
Right.
Okay? All right. Okay, now, so what we're going to work on today is two skills. One is the skills for functions, which look scary but are very simple. Look scary but are very simple. And then after that, we're going to jump into working with 3 variables, changing it to 2 variables so that we can use Kramer's rule to find the 2 letters that we don't have. Okay? Okay, now, functions. All right, what this is saying is that I'm giving you a function. And in this case, the function is what? What's the function f? What's it say? 2x plus 11. So f is 2x plus 11. Okay, now, here's what you need to find out. What does f of 2 mean? All right, what's the difference between this equation and that equation?
You plug the 2 into the word.
Well, instead of plug, let's use an R word. We replaced the x with a 2 in the function notation, and then we replaced an x with a 2 in the equation, and then solved it. Okay? Now, that's detestable, right? Almost every higher level math test that you have is going to have a function notation problem that's very similar to this. All right? If you know what it means, it's a slam dunk. If you don't know what it means, it freaks you out. Okay? So because we want to not be freaked out, the less amount of freaking out, the better. Right? So we've got to just understand what this means.
Yeah.
Okay? All right, so does that make sense? All right, so it doesn't matter what number I put in here, you're going to replace it. So now, this is the hard part. What did I do in the blue? Ooh, do in the blue. What did I do in the blue? What did I replace the... Go ahead.
Replace x with w.
All right, and so therefore, I have to replace x with w plus 3, and now I have different math. Right? When I distribute the 2, I get 2w plus 6 plus 11, which is 2w plus 17. Right? So it's the same thing, only this is what? A little bit more difficult, and it takes maybe just a little bit longer to be able to come up with the correct answer. Okay? Now, the same thing would be true if I gave you g of x. Now, why would I use g? Because I've already identified f. F, G, and H are used often. If they want more than one equation, they'll label them with different letters, but it still means function. So this function g of x says 5x minus 3. So what will g of negative 4 be? Replacing the x with a negative 4. So 5 times negative 4 is negative 20. Negative 20 subtract 3. Negative 23. Okay, no big deal. All right, now, the next 2 are important. And I wanted to, I know how I can do that. I should have, here it is. Okay. All right. this is called a composite function. What did I replace x with here? What did I replace the x with? With f of x. So I took all of this and I put it where the x was. No, it's not terrible. It just looks ugly, doesn't it?
Yeah, it's very ugly.
All right, but once you understand what it's asking you, it's quite simple. Right? And I've set it up to where this is f of x. So now I have 5 times all of this, which is 10x plus 55, minus 3 is 10x plus 52. All right, now, and so then this is f of g of x. And so here I'm going up to this x, and I'm replacing it with all of g. All right, and so now it's 2 times 5x, which is 10x minus 6 plus 11, which is 10x plus 5.
So these are called composite.
These are called composite functions. Yep. C-O-M-P-O-S-I-T-E. Composite functions.
Cool.
Okay? Now, these are the most difficult. They would be more difficult if there were squares involved.
Right.
If this had been x squared, then you would have been squaring this, and you would have to go through your FOIL method to be able to get 25x squared, 15 minus 30x plus 9, and then you'd add plus 11. Right? So the answer would be a little bit more difficult to come up with if there was a square here instead of just a linear equation. Okay, but that's the basics of functions, and the chapter on functions goes very quickly because you either get it or you don't. Okay? All right, questions on that? Okay, so understanding that when you see this, you're replacing. Now, if you have this without the definition of the function, then it doesn't mean anything. So you've got to look and see, sometimes these are given at the front of the problem, and then the work that you asked to do, like this or like this, comes afterwards, so you look above it and you've got to find. Without giving you what these are, you can't do this, can you? Right, so the two of them are going to work together. All right, questions?
Nope.
Okay, yes.
Where did the W come from?
Where does the W? What I did was I gave you a different variable here.
Oh.
And I was showing you that if you replace the x with W plus 3, then you're going to have 2 times W plus 3 plus 11, because that replaces the x with the W plus 3. Okay, so let me do that. Let me change. Yeah, I'm going to change the color of this if I can.
They give you the reasons.
Ah, where's my, there it is. All right, that's a good question. Okay, so let's. All right, does that help? Does that help? Okay, so the W at the end comes from the fact that I changed the variable. Now, I could have had this say x plus 3. Bless you. If I would have said x plus 3, then this would have been an x, and this would have been an x. All right, and I've seen a problem like that. In fact, I think I told you I was working with the girl Saturday. We had a problem like that, and I said to her, I don't think that this one problem, I don't think that's the right answer, because technically, if you replace x with x plus 3, then you have to do it this way. Right? And we usually show it with a different letter so that you see where the transformation came from. But anyway, so that's a good question, Sydney. Thank you. Okay? All right, now we're going to move into 3 variable equations. All right. Okay, here, see, for this week, you're supposed to be doing function terminology, and then you're also systems with more than 2 equations. Okay, so that's what we're going to start to talk about. Now, I think that I can get this out of the way. All right. Now, okay, here is my summary of what you're going to do with a system of 3 equations and 3 variables. Okay? All right. The first thing that you're going to do is you're going to create a 1x where possible. You're going to create a 1x. Because what we want to do is we want to know what one of the x's is. Right? Because if one of the x's, that's going to help us with our solution. All right? After you get done with that on one of the equations, then you're going to create 0 x's for the other 2 equations. Okay, and I'll explain that in a second. All right, we want to get that down. All right, you're going to multiply the new equation number 1, which has a 1x, and you're going to add it to the old number 2 or number 3. Whoa, this got crazy on me too.
This is a lot.
Oh my, there's a problem. Okay. All right. Okay, so then, all right, you're going to multiply the first equation by a number so that we end up with a 0x in the second equation and then a 0x in the third equation. When we do that, then we're going to be able to use Kramer's rule to find the x and the y and the z where we just made those 2 x's equal to 0. And I'll explain that visually in a second. And then finally, we're going to replace the value of y and the value of z in this first equation and find out what 1x is. Okay? Now, all right, so. Oh no. Okay, hurry.
So
Okay.
so many numbers.
All right. Now, one of the things is this was tutoring this past week. So some people are not freaking out as bad because they've already had an introduction to this.
Wait, so I have all this written down already. Oh.
In fact, you have the handout. Yes.
Yeah. I have it
All
printed
right.
out.
Okay.
Next Tuesday.
All right. Okay. So, all right. Now, I don't think this is going to show up. So I'm going to go to this problem here. All right, now I don't like this. I'm going to change because those are not visible. Okay, so let's look at this. If I can. All right, now. All right, what the first thing I said was we have to get a 1x.
Right.
All right. If you'll notice, there is no 1x there.
There is not.
But what happens if I take 3 and subtract 2?
1.
That gives me a 1.
Yeah.
All right? So what I would do is I would take the second equation and subtract the first. When I do that, 3 subtract 2 is 1b. Then 4 subtract 1 is 3c. And then 1 subtract 1 is 0. 19 subtract 11 equals 8. And now I have my 1.
Okay, so
Okay.
are you going to do that for all the problems? So you subtract?
Just to get 1.
Okay.
Okay? Now, I'm supposed to have another set of these.
I can't walk it. Right fast. Oh no.
Okay? Now, let's look at this one. All right? What do you notice? What do you notice about this one? What's this?
X.
It's 1x. x. So why don't I move that one to the top? Now I have 1x where I want it. Now I need to make this one and this one into 0. Well, this one's going to be easy because of what's x minus x? 0. Okay, so what I'm going to do very quickly is I'm going to take this equation and add this one. So x plus negative x is 0. 5 minus 5 is also 0. And then negative 1 subtract 5 is like negative 1 plus 5. And so that will be plus 4z. And then negative 20 subtract 2 is negative 22.
Okay.
Yes. All right.
So, what is the whole point of
The whole point is, what I want to do is get something right here that's two equations and two variables, so that I can use Kramer's rule.
Okay, so basically they're giving us an extra step. It's basically
Right, because they gave you 3 letters.
Right.
They gave you 3 letters.
So you're trying to get out 2 letters.
Right, right. We're getting it down to 2 letters because that's all we can do.
Right.
Right. The Kramer's rule works really well when you have 2 variables and 2 equations.
Right.
So that's all I'm doing. In order to do that, I'm just using the fact that I'm going to get these 2 x's as 0, and then I'll be able to solve.
So does it matter which problem?
Doesn't matter which ones. There's more than one way to do it. Right? You just try to do it as simply as you can.
Got it.
Okay. All right, now. Okay, here I have a 1 and here I have a 4. So therefore I need to add negative 4x to this second equation in order to make a 0, right? So I'm going to multiply this whole thing by negative 4. All right? Now, what's negative 4 times x? Negative 4x plus 4x is 0.
Yay!
Okay? Negative 4 times 5. Negative 20 plus negative 5 is negative 25y. Negative 20 plus negative 5, negative 25. And then this is positive 4 plus 4 is plus 8. Z, now this is going to be the hard one. This will be 80 plus 19, which is 99. Okay? Now, what's inside here, I can use Kramer's rule on. Because I have 2 equations. In fact, actually, if you look at this, you have 4x equals negative 12. I can divide this by 4 and find out that x is negative 5.5. But we're going to use Kramer's rule. Okay? Kramer's rule says the denominator. Now, this is y, isn't it? Let me get a different color. I don't like that color. This is y. Y is going to equal. All right, now we're going to take the diagonal multiply. 8 subtract negative 100 is 8 plus 100 is 108.
Wouldn't it be 0?
Oh, I'm sorry. Yes.
Okay, good.
Thank you. Thank you. I was adding instead of multiplying. All right, 0 minus negative 100 is 0 plus 100, so that's 100. And that means my y and my z have denominators of 100. Okay, now to get this, right, I replace the answers with the coefficients for the y. So negative 22 and 99, and I'm going to keep the 4 and the 8.
Right.
All right, and now we're in a place to where you're going to have to use your calculator. So, negative 22 times 8 minus 99 times 4.
Negative 176. That's, oh my goodness, so what is
Okay.
Okay,
All right, negative 22 times 8 minus 99 times 4. It should be a large negative number.
It is.
means that y is going to equal, if you divide it by 100, negative 5.72.
Yep.
All right, ugly answer, yes.
Where does the 100 come from? I'm confused.
We did the.
All right, and for the denominator, these two multiplied minus those two multiplied. That's where the denominator came from.
Okay, thank you.
Okay? All right, now what about the other side? In the other side, we're going to have the negative 22 and the 99 here, and then we're going to have, oh, wait a minute, got that backwards. That's second. Let's put it over here. Negative 22 and 99, and I'm going to have the 0 and the negative 25. So this becomes 0 plus or minus positive. So I want 22 times 25. 550. Now that one I've already figured out. All right, divide that by 100, that's 5.5. I already knew that from here.
Right.
Okay, yes.
Oh, no.
Okay, all right, now this one I just pulled this up off the internet. That's why it didn't work out very well. But that's the skill. Okay, that's the skill. Now, when you get into Algebra 3, there is a way to work this that you don't have to worry about the X, Y, and Z, and it's called a matrixing. And what you do though is that you keep working until you have 1, 0, 0, and then you have 0, 1, 0, and then you have 0, 0, 1. And so if this is a 1 and these two are zeros, whatever's there is the value of X.
Yeah.
Right? If these two are zeros and that's a 1, whatever's there is the value of Y.
Right.
Right? And that's called Gaussian elimination, which is a longer version of what we've been working on. Okay? All right, so let's look at another kind of problem, and let's see if we can continue. All right. Let's see. Yes. Question?
No.
All right. Okay. Here's another one. Here's another one that's kind of rough. All right. Now we need to get a 1. How are we going to get a 1?
By subtracting negative. No.
If I add one of these 4s and a negative 3, I'm going to get. I'll get positive 1. Right? So I can create a new equation number 1 by adding. Now, which one do you want to do? You want to do top one or middle? Let's do the middle. Okay. So 4 plus negative 3 is 1R. Right? S minus 3S is negative 2S. And then negative 2 plus negative 4 is negative 6T. And then 5 plus negative 16 is negative 11. Okay? Now, I've got to get rid of these two. Okay? So, let's multiply this by negative 4 and then add it to each equation.
Let's do it.
Okay? That'll give me a 0, right? Yes. So, negative 4 times 1, negative 4 plus 4 is 0. All right? Negative 4 times negative 2.
8.
Positive 8 minus 4 is plus 4S. Okay? And I hate that because I don't like using S's because you get S's and 2's and 5's all mixed up. All right. Now, negative 4 times negative 6. 24. 24 plus 4 plus 28. And then positive 44 subtract 4 is positive 40. Okay, now I've got this one done. I want to do the same thing to this one. Usually what would happen is these two would be different numbers, so I'd have to use a different number here. Okay? If we wanted to eliminate this negative 3, we can multiply this all by 3. Right? It would give us 3 equations. Okay, so but let's use the -4. -4 times 4, or -4 plus 4 is again 0. All right, 8 plus 1 plus 9, right? And then 24 subtract 2 is 22. And then 44 looks like 28. Okay, we can put that in the calculator to make sure, probably.
Nice.
All right, 44 plus -16.
My calculator is not going to
28.
28. Okay.
Okay.
All right. Okay. So now I have these bottom two equations where I have two variables, two equations, and I can use Kramer's rule.
Yes, you can.
Okay. So S equals and T equals. Okay. What do I need to do first? Multiply 4 times 22, which is 88. Subtract 9 times 28. I don't know what that is.
Negative 164.
164.
Negative 164.
I got 2. So did I.
Wait.
How much?
2. I got 252.
252.
Yeah.
Okay.
Wait, what?
All right. It's 4 times.
No, minus. The first thing minus the.
Well, yeah, but it'd be 8 minus 252.
80.
All right.
80.
All right. You have 4 times 22 minus 9 times 28.
Okay, you were a step
Okay,
ahead.
so it's negative 164.
All right. So that makes this negative 164. Negative 164.
No, you were a step ahead.
Okay? All right, now, the next part of Kramer's rule, which will be on your test, on your quiz next week. All right, how do we create the matrix that we're going to multiply? Go ahead.
Substitute the answers of 40
All
and
right,
28.
substitute the answers of 40 and 28, and then copy the 28 and 22, and then do your determinant. So 40 times 22 minus 28 times 28. And again, that's all calculator work.
Yes, it is.
All right, so somebody do that for me because I don't have a calculator.
Okay, so you're so smart.
Chris is fast.
40 times 22 minus 28 times 28.
It's weird.
96.
96? All right, I need confirmation.
Okay.
Let's compromise it.
Huh?
Confirm.
All right, 40 times 22 minus 28 times 28.
40 times.
No.
74?
No, what? No, you just have to.
Okay, try it again. 40 times 22 minus 28 times 28.
And
What did I say? 7 times 7 what?
6.
What do you get?
What can you do?
Subtract.
Come on, you've got to be able to do
40
this.
times
All right,
22.
40 times 22
Minus.
minus 28 times 28. And your calculator should be able to do that as one unit.
I do it as not this house.
Okay, that one actually works on this. That one will do
Guys,
this.
this is not anything like this.
So,
Was right?
yeah, this one.
On some
All right, you have
points out.
40
22
times 22 minus 28 times 28.
Nice.
If you'll notice, your calculator will put the whole thing in, and then press equals
Equals
96.
96. Okay. Now that TI-30 is the calculator that I recommend because it shows you what you put in, and it also does order of operations. And you see the parentheses on that? You see the parentheses in the middle?
Oh, yes.
So you can actually do a distribution and use the parentheses. So you end up copying a lot of this stuff in as long as it's all numbers.
Can
Yes.
we use these during like tests?
Yeah, that's legal on all testing because there's no memory to be able to put extra equations in.
dog.
So, okay? All right, so that's 96. Now, somebody take 96 and divide it by negative 164.
96 divided by negative.
That's
ugly.
I don't like it.
No, they don't like it.
Oh, that is ugly.
0.5853658.
Okay, because it was, that, I thought that was a, oh, I know why, Okay, this is not the numbers, because this one didn't give me answers. Okay, so let's go back.
It's thin and it's smarter than the other. It's like you.
All right.
Thinner, smart. He's so lost. Wait, no. I don't like this one. It's okay. I still love it.
All right, let's go here. All right, let me.
Hey, is this a whole other problem? Is this a whole other problem?
Yes, yeah, we're gonna go to a new problem.
Yay.
I just pulled those off, and I didn't check to see, those didn't have answers, so I didn't get to see whether or not they were whole number answers. These are supposed to be whole number answers. Okay, how do we get a 1?
By subtracting 3 from 2.
All right, 2 from 3. Okay, all right, that'll work. What would happen if I multiplied this second one times 2 and then subtracted the 5?
Oh, that worked too.
That works too.
Wouldn't that also work? All
Wouldn't that be like
right. Or
that?
I could multiply this one times 2 and subtract the second one, because that would give me 4, subtract 3. So there's more than one way. There's more than one way. As long as you have an odd number and an even number, you can get a value of 1. The problem is, doesn't have it here. One of the problems had all even numbers.
Right.
Then you couldn't use the first one. You have to move to the next one.
Right.
All right. So what do we want to do? Want to take
I just want to
take 3, subtract 2?
2.
All right, that's the easiest. So what is 3 subtract 2?
1B.
1B. So I have 1B,
And then 4.
and then 5 subtract 1
4B.
plus 4B, and then 5 subtract 1 again
4C. What did that
is
be?
plus 4Z, and then 34 subtract 11,
23.
23.
I'm so sorry.
Okay? Now, what am I going to do with this to get rid of the 3?
You're gonna wait.
Multiply by negative 3. And a lot of times, I put that out there so I see it.
Right.
Okay.
That really helps. So, negative 3 times 1, negative 3 plus 3 is 0. Now, negative 3 times 4, negative 12 plus 5, negative 7.
Right.
All right, negative 3 times 4, negative 12 plus 5.
Same thing.
All right, is negative 7. Z, now here's a rough one. Negative 3, here's your calculator work. Negative 3 times 23,
Negative 69.
all right, plus 34.
Negative 35.
Say again,
Negative 35.
negative 35.
What is operation again?
Okay? All right, did you see that calculator through the whole thing? You need to talk to that.
You baby.
Yes.
Oh,
Okay.
I'm
All right,
like,
now,
so
how do you get rid of the 5? How do we get rid of the 5? We multiply by negative 5, but I could also get rid of the 2. All right, let's get rid of the 2, because the math is easier. All right, so negative 2 times 1, negative 2 plus 2 is 0. All right, now negative 2 times 4, negative 8 plus 1, negative 7b. All right, negative 2 times 4, come on, negative 2 times 4, negative 8 plus 1, negative 7z, and negative 2 times 23, right, that's negative 46, plus 11 is 35. What do you see here?
They're the same
The
equation.
same equation.
Oh my gosh, I can get rid of one.
Okay.
Can you get rid of one?
Hmm?
You get rid of one?
Well, okay, I think what we've got is we've got 2 lines that are the same. All right, well, let's try the 5. Okay. All right, 5 times negative 5, 0. Okay, negative 20 plus 6. Negative 20 plus 6.
Yes.
Right? Now, negative 20 plus 3. And then 5 times, all right, here's calculator work. Negative 5 times 23 plus 42.
Negative 73.
Negative 73, great.
That's the one. Ladies
Okay.
and gents.
Now here, we have 2 equations, 2 variables. So now we're going to use Kramer's rule to solve these 2.
Okay. I can do that.
Okay? Go ahead and do that on your paper.
Paper.
Yes.
I can do that.
What is it? The
Yeah. Negative 70.
What is it?
The denominator is negative 217. You want to do 217?
Boy, I don't
That's
know.
what my calculator says.
Okay, so you have negative 7 times negative 17 minus.
Wait, not times wait, negative 7 times negative 17
Minus
negative
negative 14 times negative 7.
21.
Yes, thank
So,
Okay, so 21 here and 21 here. Did everybody else get 21?
Yes.
All right, anybody have a question on how to get it?
No, sir.
All right, Sydney, you all right? All right, how do you get it? Huh? No, you don't have
you
it.
don't add it
You
up.
multiply these 2 minus multiply of those 2. Okay, you've got to learn how to do that quickly. Okay, all right. Now, to get the numerators, we're going to replace the 2 answers and put those here as negative 35 and negative 73, and then we're going to copy negative 7, negative 17, and again, we're going to do our determinant. Negative 35 times negative 17, and then minus negative 73 times negative 7. Hopefully,
It's a big number.
that's
Negative 73.
Wait,
And,
that's
42, maybe?
I got 84.
84. I like 84.
Yeah, I got
You
it.
know why? You know why?
Why?
What's 84 divided by 21?
I don't know.
Try it.
I'm doing
no.
84 divided by 21?
I like
It's 4.
That's what.
So our V is 4.
Cool.
All right? We know that our V is 4.
I love Kramer's rule.
All right, now, let's do Kramer's rule on the other one. The other one, we have the negative 35 and the negative 73 here, and we have negative 7 and negative 14. And again, Sydney, which numbers do we multiply?
Wait, isn't that the one we just did?
Now, they're almost the same. All right, what I did this time is, see here the 35 is in the first place, now the 35 is in the second place, and I copied those first 2. But these numbers are almost the same, that's why it looks so weird.
It's 21 over 21.
Oh, okay. So this is 21 over 21, which means that the Z is 1.
Which?
All right, now here's what I have. I have 2 times B plus 4 plus 1 equals 11. How much is 4 plus 1? 5. So if I subtract 5, I get 2B equals 6, and so so B is 3. So 3, 4, 1 is the solution point. Okay, and almost every problem that you're going to have in Algebra 2, they're going to give you whole number answers, and so it should work out that sweetly when you use Kramer's rule.
Okay. Sweet.
Okay?
Cool.
All right, now, so what have you learned on this? Okay? All right, some have learned a little bit more on how to apply Kramer's rule when you have two equations, two variables. Right? If you get good at that, that will serve you on a lot of the tests that you have, right? That involve systems of equations. Kramer's rule works every time. The only difficulty you will have is if you end up with a 0 in the denominator. Are you allowed to have a 0 in the denominator? You can't divide by 0. So therefore, if you have a 0 in the denominator, you have the null set. It doesn't work.
Cool.
Okay. All right. So, all right. But most all of the systems of equations you can use. Now, on your quiz next week, the first problem that will be a system, they ask you to solve using any method you want. The second one, you have to show me your work for doing what we just did. Now, it's not going to be 3 variables. It's only going to be 2 variables. All right, but what was the difference? How did we get from the 3 variables to the 2 variables? We just used manipulation of these equations by multiplying every term by the same number and either adding or subtracting 2 equations together. Okay? All right? I'm glad to hear that you get it. That's
When I
good.
go home, I won't get it.
No, you will too. You will too. Okay, now what time? We have 10 more minutes, so
What time is it?
it's 20 after.
Oh, 25. We got it at 25.
25, that's 10 more minutes.
That was 10.
Shh.
Okay.
No question.
All right, now see how easy these look? Let's just look at these. All right, this has 6, 6, and 5.
Oh, yay.
So can you make a 1?
Yeah.
Yes, okay. Look at here. 5, 3, and 2.
Yes.
It's easy. What about this one?
No.
Oh. All right.
Why?
So therefore, we're going to have to use a different letter. We can't use the first one. But look at the second one.
Yay.
All right. Can I use the second one?
I don't know.
All right. Because 3 subtract 2 is 1. Right? So what I'm going to end up doing in this one is I'm going to have my zeros here and my 1 here. Yes.
Okay, so if you do that, when you do the Kramer's rule, would you just use the 4 that's on the
Yeah,
outside?
either that or is A plus B the same as B plus A?
Yes.
All right? Then why don't I do this for my sake? I'm going to take these letters and I'm going to move those to the front so it's the way I like to see it. Right? Okay, so now my first one is going to be 3 subtract 2, which is 1C. Right? And then 4 subtract 4, which is 0A.
Yes.
And then 6 subtract 2, which is plus 4U. And then 45 subtract 28 is going to be 27? No, 17.
What are we doing?
45 subtract 28.
45. Yeah, 17.
Okay? All right. Now, so now I have this, and now I have to multiply this one by -3 to get rid of this bottom. Right?
Right.
And then I'll multiply this new one times -5 to be able to get rid of the top one. Okay? So let's do that.
Okay, that's.
All right. -3 times C will be 0. Then -3 times 0 is 0 plus A is 4A. And then -3 times 4, negative 12 plus, I'm doing this one, sorry, plus 6, negative 12 plus 6, negative 6u, and then here I need help. Negative 3 times 45, no, I'm sorry, negative 3 times 17.
Negative 17 equals negative 51.
And then I'm adding 45.
Plus 45, negative 6.
Negative 6.
Gosh, Dr. Chris, this all be so fast.
All right, and then I do the same thing to the second one, but then just make sure that you understand that this is A and this is U,
Yep.
and then you're going to put it back into this first one to find C. Does that make sense? Okay, all right, so what you're working on, all right, in chapter 5, you're going to be doing systems of two equations and use Kramer's rule, right? The elimination part, one other thing, the last thing I'm going to be talking about. Let's do it right here. Okay, 5x plus 3y equals 15. 5x plus 3y equals 7. Okay? If I try to make a 1, can I make a 1?
No, you cannot.
No. What happens when I add these two together?
10.
I'll get 10 and 6, but when I subtract them,
You get 0, 0.
I get 0 equals 8. How often does 0 equal 8?
Never.
Never. And so the answer is the null set, because these lines are parallel with different intercepts.
Okay, so I get that part. Okay.
Right? If you got 0 equals 0, for what values of x and y does 0 equal 0? All values.
I was going to say.
Right? Every value of x and y will at 0 equals 0. So this is infinite number. And in that case, what happens is this is a multiple of the last one.
Gotcha.
See, if this had been a 15, then those lines would have, then this would have eliminated the 0 equals 0. And so if I multiplied this by 2 and had 10, 6, and 30, when I had a 10x here, to be able to get this, I'd have to multiply by negative 2, right? This was plus 6y. Negative 2 times 3 is negative 6, and then this equals 30, and negative 2 times 15 is negative 30. You'd end up with 0 equals 0. So when these lines are multiples of each other, they line on top, and then you have an infinite number of solutions. Okay? All right? Okay, so that is the quick work for chapter 4. All right, please do the practice. Do the practice. If you practice the problems that are here, right, then first of all, you're going to get much better at not getting freaked out when you see them. Right? And second of all, it becomes easier to be able to do the multiplication. Okay, especially when you get to the 3 variables. If you've practiced with the 2 the way that you're supposed to, when you get to the 3, it'll be easier to work on. Okay? All right. You owe me a quiz, and we are going to stop for the day. Good job.
Thank you. It's 4, 4, 4, 6. It's on proof.